Okay, so this is the first lab, and the goal for us is to eventually complete a basic AWS infrastructure. And we're going to start off by creating a virtual private cloud. Now, before I get started on the lab and we go over the lab instructions, one of the goals of this program, this entire BAT program, is not just to spoon feed you information and for you to follow the step-by-step process of completing a lab, but want to more focus on as well as where to find the information. I'm not reinventing the wheel when it comes to creating these labs. So, for example, go to Google, type how to create a VPC in AWS, right? Hit search, and your first search result is going to be from the AWS documentation page, right? And you create a VPC from the Amazon Virtual Private Cloud, right? And if you click on it, okay, you'll get the step-by-step instructions right here on how to do it. Now, I'll go over the instructions in detail with you, and I think that's the benefit of the course. And I'm going to explain things as we go along, and some tips and tools, and even to help you prepare for the exam. But I want you to know that the internet is out there for you to troubleshoot and find information, right? You can't put everything in a course room. So just keep that in mind. So our goal is not only to give you the hands-on experience and you could do the labs over again, right, to reinforce that learning, but also where to find the information, because that's how it is in the outside world. I mean, there's no textbooks lined up on people's desk, and when they get a troubleshooting call or they're working a troubleshooting issue as a team, I mean, a lot of research over the internet is going on, and you can find out just about anything on the internet. So keep that in mind. So that's the first thing I wanted to show you. The second thing I wanted to show you is I'm going to pull up a chart so you'll get an idea of what we'll do for the course. Okay, I built this chart using lucid.com, Lucid, and I'll go over that in a second. But this is the AWS infrastructure chart that we're going to piece together kind of lab by lab, and I'll go over that in just a second. I just want to show you, if you go to Lucid, right, you can build charts for free in your browser. And for example, I did one here. Here it is in the browser, and when you're done, it's kind of weird because again, you're paying for, you're not paying for anything. If you click File and you go to Export, let's just say you choose PDF, okay. Notice there's no download link to download your chart, but if you close this comment only sharing window, then the download button appears. And this is the preview of what's going to be downloaded. So that's an option as well. Whenever you want to submit assignments, for example, and you want to, or do a PowerPoint presentation, or you want to submit a graph or a chart, so, like this, for example, you can go to Lucid and do it for free. So I just wanted to point that out there as an additional resource for you. Okay, so with that said, I'm going to close this window, and we're going to go back to the chart and what we're going to do for the lab and subsequent labs as well. Okay, but before we do, because this lab takes a while to load, you're going to go to your AWS Learner Lab course, and you're going to click on modules, right? And when you're on the module area, you want to select Launch AWS Academy Learner Lab. And long story short, it's basically a sandbox, a playground, so to speak, where an instructor can create their own labs and then show students how to, step-by-step process on how to complete a lab. Now, we work under a budget, and so notice you get a $50 credit. And the concept is we can't exceed the $50. So as I build these labs, I'm going to try to choose the free tier services whenever possible. And we're going to go over some basic things on how to, gateways and load balancers, and try to keep the cost to a minimum. And in some cases, we'll break down the lab so you're not incurring an ongoing charge. Okay, so that'll be my responsibility, is make sure we don't exceed that $50. So as you can see, I've spent 10 cents, right? I guess that's what it looks, right? Because I went through the lab because I wanted to test the playground out and make sure that the sandbox works, and it does. So what we're going to do, we're going to click on Start Lab. Okay, and again, your AWS light is yellow here. We got to wait for that to go green before we can access the console. So while we're waiting for that to load, I'll go over the chart. So let me pull it up here. Okay, so the first step, and what we're going to do, is just create a virtual private cloud. And let's just start with the beginning, right? And at the very top, you have the AWS cloud, which is the entire AWS infrastructure, right? All the regions, all the availability zones, all the countries in which AWS is hosted in, the entire AWS infrastructure is represented by that black box, right, with the black outline, right? And in the upper left-hand corner, you can see AWS clouds. So you start from there first. And then second, what you do is you choose a region, okay? And the region that we're going to choose is the Northern Virginia region, and we'll create a VPC, a virtual private cloud, from that region. So that's kind of like the second thing, right? And you see the green rectangle with the green lines, and it says VPC, right, in the upper left-hand corner. That VPC resides in a region. Okay, so again, we'll choose North Virginia because it's closest to us. And then after we select the region, we create a virtual private cloud, which is our network infrastructure. That's where our network infrastructure is going to be hosted in, right? Look at it as a room where you're going to put all your servers and all your file servers and email servers and web servers and routing and switches are all going to go into a large room. And it's the place where your entire network infrastructure is going to be hosted. And, that would be a physical network infrastructure. For the cloud, it's virtually, right? So the VPC represents our virtual infrastructure in which all AWS resources will be hosted in, okay? Then we get to the third step, right? And then within a VPC, or virtual private cloud, in the North Virginia region, we're going to select availability zones. Now, availability zones are actual physical data centers within that region. And as you can see, I've selected two of them, an availability zone A, and it's represented by that light blue rectangle, right? And then you have an availability zone B. Okay, now why would you want two availability zones? Well, this tends to be a certification exam question. AWS recommends a virtual private cloud with at least two availability zones. And remember this term a lot, for high availability. High availability means that, in fancy terms, that if one availability zone goes down, or if one data center goes down, you have the other data center to keep operations running as normal, right? So you have two, but if one goes down, you still got the other. The technical term for that is fault tolerance, right? And then you want redundancy, and redundancy kind of means that you can use both availability zones to distribute workload evenly between Amazon resources. So instead of just having one as a backup and it's just collecting dust, waiting for the other one to go down, and it may never go down, why not use both of them? And, you can share resources evenly. You can distribute workload evenly, right? It's just like, I'm a point guard, and, I've got LeBron James and Michael Jordan on my team. So the first play, I give it to LeBron James and he scores. And then next time I get the ball, I give it to Michael Jordan and he scores. And I just keep balancing the workload between the two of them. And so, and instead of waiting for one to get hurt or injured or to take a rest, right, you can use both all-star players simultaneously by distributing the workload. It's just an example. But in our example here, we have an availability zone A and availability zone B. And again, it's two separate data centers. Amazon does not disclose the locations of its data centers. So you're not going to be able to see like availability zone A is, I'm just making this up, Norfolk, Virginia on Main Street. We're not going to see that. And so Amazon doesn't publish the locations of its availability zones, but they are separate physical data centers. So you have true fault tolerance, disaster recovery, because if one physical data center goes down, you still have the other physical data centers. So again, remember, for highly available cloud infrastructures, Amazon recommends a VPC with at least 2 availability zones, 2 or more. Okay, so keep that in mind. That more than likely will be an exam question somewhere. Okay, so within each availability zone, right, eventually as we go further along with these labs, we'll create Amazon EC2 instances. And I'll use the Amazon Linux free tier operating system to keep those costs down that I mentioned before. And we'll place them in public subnets, okay? And then from there, we'll have backend databases in private subnets. And I'm not sure if we're going to do this yet or not. I'm debating between, using an internet gateway and a NAT gateway. I'll explain this briefly. If the Amazon EC2 instances have public IP addresses, right, and we use Elastic IP, so they're assigned public IP addresses, they just need an internet gateway to go out to the internet. They don't need network address translation because they already have public IP addresses. Now, the databases, which have private IPs, will need a NAT gateway because private IPs are not routable to the internet by default. So the NAT gateway would have a public IP associated with it. And then you'd use, the private IP addresses that go through the NAT gateway would be mapped to a public IP and then go out to the internet. It's the same concept as your home network, right? On the inside of your home, all your devices have private IPs, but whether it's your AT&T router or Comcast router or other internet service provider router, right? It's doing network address translation because it has a public IP address. And those private IPs get mapped to a public IP before they go out to the internet. And again, this is optional because this is only if your databases need access to the internet. And in many instances, they do not, okay, because the public Amazon EC2 instance is the front end application. And for example, as you type in information on the EC2, it gets downloaded to the database, right? And then these databases actually communicate with one another for fault tolerance and redundancy. So they actually exchange their database information with one another, okay? So NAT gateways are not always required for private subnets, only if devices in those private subnets need access to the internet. And then somewhere down the road, we'll create an S3 bucket to host a website, just to show you how that works. An S3 bucket normally just resides on the Amazon infrastructure, and S3 buckets can be used for one or two purposes, and that is to host static websites or as a file server. And there's a lot of things you can do with that file storage in Amazon that you couldn't do with a normal file server. You could set policies and so forth on an S3 bucket. Okay, so But today, for today's lab, we're going to start with how to create this green box right here, this virtual private cloud, how to subnet it, and how to create our availability zones, and how to assign a public subnet and a private subnet to availability zone A and availability zone B. Okay, so let's go ahead and just get started with the lab. Okay, I'm going to pull up my browser, and now my AWS light is green. So I'm going to go ahead and click on that. And for now, we're just going to create the VPC. Okay, we're going to build this lab gradually in steps. Okay, now there's several ways you can access the VPC application in the AWS console. If you used it recently, it would show up here. Okay, so if you create a VPC and you go back to your sandbox, you'll see it in the recently visited because you used it. You can also search for it. You can type VPC, which is probably the easiest way, and it pops up. Or use the services here. You click on services, right? Scroll down to not compute, because that's where your EC2 virtual servers are located. You would scroll down to networking and content delivery, click on networking and content delivery, and then select VPC, right? So there's three ways you can access it, and whatever way you choose is fine. I don't know, the services tab might be useful only because you get to see what's available under each main service. But, I'll leave that to you as far as how you want to access it. So I'll click on VPC. And the first thing you want to take note of is what region you're in, right? So that'll be in the upper right-hand corner. You want to make sure it's North Virginia. If it doesn't say it, you could just click that drop-down arrow and click on the North Virginia region, okay? And this is your username, okay, what you're logged in as. But pay attention to the region, okay? So we're going to start by creating a VPC. And so we're going to click the Create VPC button. And as far as the VPC settings are concerned, we're going to leave it as VPC or more, okay? Now, we're going to auto-generate a name tag. Name tags are a way of categorizing and organizing your resources. So, for example, if you're creating several EC2 instances, and some of them are web servers, and some of them are email servers, right? For 3 EC2 instances, you can tag them as web servers, and you can organize your AWS environment, and then you can do the same for the email servers. Okay, so for the VPC, as far as the name tag, I'm just going to call it lab VPC. Okay, and you can put a dash in there, right? I don't know if you can put spaces in the tags. You might be able to, but I always get around that by putting a dash or a hyphen between words. And now I'm going to go back to the instructions. And as you can see, we've done step 3 and we've done step 4. Now for the IPv4 Cedar block, okay, we're going to create our own unique IP address range. Now the benefit of doing that is you want to create an infrastructure where you can look at an IP address and know exactly where it's coming from. AWS gives you a default VPC, and you could keep it, but you get the subnetting scheme that they provide automatically, and you might want to create your own. And I'll give you an example. This is how I do mine. Now, for the IPv4 Cedar block, the network address for the entire VPC by default is 10.0.0.0/16, right? And I don't want to get too much into the subnetting lecture, but for each octet, there's 8 bits, okay? So there's a total of 32 bits for the 4 octets, right? 8 times 4 is 32. What the /16 means, the first 2 octets, and I've highlighted them, represent the network portion of the address, and then the last 2 octets would represent the host portion. Okay, but we're going to change this. We're going to still keep the /16. I'm going to use 172.16.0.0/16. Okay, so we're going to change that. We're not going to use IPv6. There's no need for IPv6 in your AWS infrastructure, really, because you don't have thousands of resources in your AWS infrastructure, and there's no concern with running out of IP addresses. So we're going to leave that no IPv6 cedar block. Okay, now Tennessee, I'm going to explain that. Okay, Tennessee. Now, I'll try to give you an example is, are you going to, when you move into a house, are you going to buy a house or are you going to lease or rent a house, right? So when you're choosing a physical resource and you want some dedicated space, and it could be because of security reasons you're required to, if you choose dedicated, then your infrastructure is going to reside on its own unique hardware infrastructure in the AWS data center. No other organization or no other resources will be partitioned on the same physical device as yours. Okay, and you may need that for security reasons, right? That's why in future courses we go over a little bit about regulatory and compliance issues and see what the requirements are, because in some cases you may need to have a dedicated tenancy. Dedicated tenancy is going to cost you more, right? Because you're reserving that piece of hardware solely for your organization instead of sharing it with other organizations. And you may say, well, sharing is a security concern. I guess it could be. Yes, it could be an argument. With that said, as part of your agreement with AWS and responsibilities, AWS guarantees the physical security of its resources. So if you leave the Tennessee as the default and you're going to be shared on the same hard drive, for example, as another organization, only on different partitions, AWS is going to guarantee that security. What they're saying is your data will be protected from another organization's data on that same physical device. Okay, so that's what Tennessee means. And as you can see, you got 2 options. You got the default or dedicated. Obviously, we want to leave it as the default because, again, we want to keep our costs down. Number of availability zones. Again, for a highly available infrastructure, AWS recommends 2 or more. So we're going to leave it as 2, but we want to customize them. Okay, so we're going to click Customize, and we want to choose the availability zones. Now, it doesn't matter which one you choose, but as you can see, these are separate data centers within that region. Okay, if you ever saw an AWS data center, they look like airports. I mean, they're huge, but anyway, make sure, just so we're all on the same page, you choose the US East 1A and 1B availability zones. So that'll be, the first one will be 1A, and then the second one will be 1B. And then the number of public subnets will be 2, and the number of private subnets will be 2, because we want it to look like our diagram, in which we have 2 public subnets and 2 separate availability zones, and 2 private subnets and 2 separate availability zones. Okay, so we'll have 2, and then we'll have 2, and then we'll customize our subnets. Okay, now notice what AWS does with the subnetting. They use /20s, in which they're using the first 4 bits in the 3rd octet to represent the network portion of the address. And if you don't know how to subnet class B addresses, that could be complicated for you. I'm going to make this more simpler. Okay, I'm going to use 172.16.1.0/24. Okay, what this means is 172.16.1 is the public network address for the public subnet in US East 1A. Okay, and then for the public subnet in US East 1B, I am going to use 172.16.2.0. Well, let me see what the diagram reads. So make sure I got it matching the diagram. Okay, I'm using the odd numbers in the third octet to represent the public subnet, and I'm using the even numbers in the third octet to represent the private subnet. So for the second subnet, it'll be 172.16.3.0 /24. Okay, and I got to click on that arrow again. I got more work to do. Okay, and so we got to configure the private subnet in US East 1A, which will be 172. And you can feel free, if you know how to subnet, feel free to use your own, but just keep in mind you're going to have to remember your subnetting scheme. Okay, so we're going to choose 170.16.2.0 again because the even number in the third octet, right, will represent anything even number. We know it's a private subnet, and then in the last private subnet, it'll be 172.16.4.0 /24. So what we did, how we subnetted it out is we have a lot of options as how we subnet that third octet. What I chose to do is turn all the 0 bits in the third octet on as 1 bit. So my network address, the first 3 octets /24 represents the network portion of the address, and the last octet is the host portion. Okay, and I can have up to 254 hosts for each subnet. Okay, now 172.16.1, 170.16.2, 3, 4. Again, odd numbers, public subnet. The even numbers are the private subnets. Okay. For NAT gateways, for now, we're going to choose none. Okay. If we choose them now, we're going to incur a small charge for it. Okay. So, because a public IP address will be assigned to it. Okay. Now, for VPC endpoints on the S3 gateway, for now, we can leave that as is. That will allow our EC2 instances to communicate with our S3. Okay, our S3 bucket, which can be used to host the static website or for file storage. So we'll just leave that as is. We're going to enable DNS host names and enable DNS resolutions. And then we're going to click on additional tags. And we don't need to add a new tag because we already created a tag for our VPC infrastructure, which is lab VPC. Okay. And then from there, it's as simple as creating the VPC. As you can see, it's changing all the black check marks into green. And then once it's done, we'll go ahead and click on the View VPC. Okay, so notice the status of it. VPCs come up right away. It's available. Now, up at the very top here, if you click on your VPCs, and if I scroll down here a little bit, notice they give us a default one, okay? And we have our lab VPC. And so you just want to remember which one is yours. And you can do that by the VPC ID. And and these are all hexadecimal numbers. But if you just remember the last two, the default one is A6. We're not going to use that. We're going to use A5. Okay. Now, later on, you could delete the default VPC and just keep the lab one up there. But for now, I'm just going to leave it there. Okay. Because the goal of this lab is just simply to create a VPC, and we can examine certain information from here. What we'll do is we'll click on it. And we'll go ahead and first thing we're going to do is look at that VPC ID. right? It ends in EA5. You want to verify the tenancy as default because that's going to save you money. It's not the default VPC. We created one ourselves. Okay. We don't have network address translation going on now. Right now it's available. This is the IPv4 seeder block we created for that default VPC. Okay. And then that's probably the main pieces of information. Now in the left pane, I want to show you the subnets we created. So in the left area right here, click on subnets. And we've got a bunch of subnets, and a lot of them are from that default VPC. And let's just scroll over, and you'll be able to see which ones are ours. I might have to hit refresh. There they go. You have to hit refresh up here to see your subnets that you created. And notice they're not in order. You got the 20s in here mixed up with the 24s. Okay, and so you could see ours, they're just not in order. And again, we've given them names. So we've got these are the subnets we're going to work with for our lab. Okay, so we got a public subnet in US East 1A, and we have a public subnet right here in US East 1B, and then we got a private subnet in US East 1A, and a second private subnet in US East 1B. Okay, and you can see how they're subnetted out. Okay, you've got we got a 1.0 here at the bottom, we got a 2.0 at the top, we got a 3.0 here in the middle, and we got a 4.0 here in the middle. And so that's where you can view your subnetted information. Okay, route tables, these are automatically set up for you. And basically how the route tables are designed is so that you can communicate with any device in your subnet or in your availability zone. And so, for example, if we click the private subnet in US East 1A, and remember that has its own unique subnet. And if you click the subnet associations tab, okay, you can see the subnet that is associated with that route, 172.16.2.0, which is the private subnet in US East 1A. Here it is right here, 2.0, the private subnet. So anything in here, there's a route table for, so we can communicate with each other. Okay, and if you click on routes, okay, notice it says 172.16.0.0 local. Okay, what that means in a nutshell is you can communicate with anyone in that VPC. Okay, there's a local route for it. And so that's set up by default. And normally we don't have to do much with route tables. Only when we start creating gateways, because eventually if we want to reach the internet, where do we send traffic to? Like if I'm a EC2 instance and I want to send traffic out to the internet, who do I send it to? I need to send it to my gateway, right? Or if I'm a database in a private subnet, right, and I need to go out to the internet from time to time, maybe for updates and downloads to my operating system or my database server software, I need to send it to my NAT gateway. I'll need to create a route for it. Okay, so yes, when we start adding gateways and NAT gateways, routes will need to be created for it. Okay, if you click on Internet Gateway, okay, there's an automatic Internet Gateway created for us for our lab VPC. IGW stands for Internet Gateway. So that when you create your VPC and you create public subnets, right, they automatically create a gateway for you. Notice they don't create a NAT gateway, right? And the reason why they don't create a NAT gateway for you is because you right now you're not paying for anything, right? And so a NAT gateway is going to cost you money, so they wouldn't throw that on there. You're going to have to manually create the NAT gateway yourself, or when you're doing the walkthrough process and creating a VPC. But if we click on the gateway, you can see that the gateway is attached for the VPC ID. and you want to make sure it's attached and you got the ID for it, right? Which VPC it represents, EA5, right? Now keep in mind, private subnets, right, with private IPs only, a gateway isn't going to work. Okay, they will need a NAT gateway. But when you create your EC2 instances and you assign them elastic IPs or public IP addresses, then all they need is a gateway because they already have a public IP. Okay, so you have your internet gateway. If you click on elastic IPs, nothing should be in there yet, right? Because we haven't assigned any elastic IPs. And then if you go back to your VPCs at the top, okay, what I want to show you is I'm going to close this window here just to make more room, okay, for Amazon questions. I want to show you the resource map because it'll show you how it all ties in. And I'm going to try to scroll this up as much as I can, okay? And it's easier to go backwards, but we'll start with forward. At the very top of your hierarchy or infrastructure, you have your VPC. Right? And within your VPC, you have two availability zones. And within two availability zones, you have your public subnets, right, which are color-coded in green. And you have your private subnets, which are color-coded in blue. So you have a green AB and you have a blue AB. Now, if I point my mouse over the green AB, notice that this public subnet is tied into a public route. And same thing for the USB public subnet. I got both of them highlighted and they both tie into this public route. Now for the private subnet, okay, it has its own unique route, which says it's just a local route to 172.16.0.0 anywhere within the VPC. It can't go out to the internet though. And same with the second private subnet, it has its own route as well. Okay, now if you move over to the routes, okay, you could see the connections that are set forward, right? So we have a S3 gateway. So if we create later on in our lab, if we create an S3, whether it's for a website or for file storage, we'll have a VPC endpoint for it. And that's what this VPC means, VPC endpoint, which means that the S3 doesn't need a gateway, but all the resources in our virtual private cloud will be able to reach the S3 bucket, okay? So the private routes will be able to reach the S3 bucket, which is helpful because when we put databases in there, the S3 bucket can be used as a backup for the database as far as hard data is concerned. Okay, now if you point your mouse over the public routes, right, public IPs, right, will have a connection to the gateway, right? But notice the private routes don't have a connection to a gateway. All they have connection to the S3. Okay, so that resource map allows you to visually see how everything ties in together. And you can click on Cedars. Okay, and again, you could see your main network address for the VPC. Okay, so we're going to stop there. That concludes the lab on creating a VPC. As you can see, I did a lot of explanation into it and not just going through the step-by-step process. Now, you don't have to do anything. You could just say your environment will be saved. So we can pick up where we left off, and maybe when we pick up where we left off, what we'll do is in our next lab is add some EC2 instances, and maybe from there we'll create an image from one. So if you ever need to add another one, you don't have to reinvent the wheel and go through all the process. You can just select an image and it'll use the exact same EC2 instance. And we'll set up that EC2 instance to be a web server. And so we'll do some Linux commands on it to start the web server process and to load a website onto it. Just something very basic. Okay, so this concludes the first lab. Take care. Have a good rest of your day.